Well, welcome. Last session of the day. Please don't fall asleep. I'm tired. There was so much going on today, and it is, it's been a great conference so far. But hopefully I can keep you all awake with a Kafka talk and a Pi talk. There's a lot going on here. But just to let you know, my name is Danica Fine. I am a developer advocate at Confluent. That's pretty much all you need to know about me. There's a couple other facts, though. If you have heard of me, which is a very ridiculous thing for me to assume that, like, oh, you've heard of me before. But if you do, you know that I like houseplants. I need to start with that because I need to. It's my personality, okay? But I am more than that. I also like to bake, okay? How many of you bake or cook or make it part of your personality? Wonderful. Okay, so that makes me feel better. So I'm that person in my friend group that is inevitably, and also my family, like every event, every dinner, every party, whatever, what are you going to bake? What are you bringing? It's nice to be wanted like that, but also it gets exhausting. But it's a fun opportunity to experiment, so I always have to show up with something, right? Busiest time of year, holidays, okay? End of the year, especially now that, I live away from my family and everyone does Friendsgiving. That's like such a thing now. Like I go to 5 Friendsgivings every year, which is entirely too many. That's too much food. But I have to show up with something, right? I can't just show up empty-handed, so I have to bring a pie. And that's where this is where the journey begins, okay? It all stems from that. So we're gonna talk about pie a lot. I hope you're ready, okay? And you might be asking why pie? Why does this actually matter? So again, I have this reputation for baking pretty nice things, or I think they're really good. Everything that I make is incredible. I cannot do anything wrong, But other people that I bake for have preferences and favorites and opinions and thoughts and dreams and whatever. How dare they? So the people pleaser in me says, whenever I show up with something at a party, I need to make sure that the largest number of people there are going to enjoy it, okay? And I can't leave anyone out. I need to make sure that if Nana's pecan pie is their favorite, well, I need to make Nana's pecan pie and make them happy. Exactly. So, and sorry if you say pecan or whatever. You know what? I'm not sorry. So, yeah, it's the people pleaser in me. Like, even if I'm like being the nice person, I'm showing up with something out of the goodness of my heart, I still want to make sure that I make the most number of people happy, right? So whenever I go to these Friendsgivings, the many that I have to go to every year, I send out a couple texts. And by a couple, I mean a lot, okay? Because I'm going to many. What should I bring? What's going to make you happy? What's going to make this meal the best meal for you? Let's round this out, okay? But that's a lot of information to keep track of. I mean, not like a lot. We're not talking big data a lot, okay? But it's a lot for me to maintain. I don't like to think about it too much. So I figured, okay, what am I going to do? Text them all and write things down? It's Nana's pie, but I don't need to use Nana's scratch pad too. That's ridiculous. So I don't know, Google Forms, I guess, when this came out, I think we overuse Google Forms. I don't think it's right for me to send out a survey to my friends through Google Forms. That's really lame. And also I need to still message each one of them individually. So, all right, we're not gonna do that. Let's get better. Okay. Kafka and Telegram-based survey issuing application. Well, that's oddly specific, isn't it? But I think it might serve our purposes here. So this huge assumption, if you've heard of me before, you know that I like to combine my hobbies, the things that I enjoy in life, with my technical skills, which really just rounds out with Kafka. I love Kafka. We can talk more about that. So I figured that if I could create a messaging-based application, on an app that my friends already use, which is Telegram, and I could issue these surveys to my friends and capture this information and then figure out what pies I need to be baking for all these events, that sounds great. That would be a great use of my time. And it's going to solve one of my problems, all right? So before I get too deep into it, let's back it up. And I want to convince everyone that this is worthwhile. I mean, this is the Real-Time Analytics Summit, so obviously there is value in analyzing things in real time. But okay, business Danica here. Do we actually need to bring Kafka into this mix? Maybe not for my use case, but also I'm going to convince you yes. So surveys are everywhere. I mean, you're going to be faced with one at the end of this session, and you're going to rate it 5. So everywhere, all right? And I think for as often as we are bombarded with surveys and as important as they can be, we don't really pay that much attention to them as businesses, like the people that are consuming that data at the end. But think about it. Think of how many surveys you've encountered in the last week. If you flew in, you probably got an email from the airline, like, how was your flight, right? Or at the post office, every time. I think it's supposed to be a random survey, but I swear, on every receipt I get, it's a survey. All right, you're special, Danica, answer this survey. Or even internally, right? How are your peers performing? Or how is management doing at the end of every quarter, right? And so surveys are a really great way for businesses to connect with their customers or even internally with people that work for them. But the only downside that I've seen is that they're typically batch processed. I mean, the internal surveys, it's like only at the end of the quarter do we actually look at those values. We don't really care until then. I guarantee the post office isn't looking at their surveys on the hour, every hour. They're batch processing them, right? And I think we can all agree, I think it's safe to say that everyone here agrees, that data is more valuable as close to when it's created, right? So we should probably be analyzing surveys in real time. All right, so I think hopefully that convinced you. There is an actual business use case for this, and this will be applicable outside of just pies, okay, I promise you. So survey analysis, this is something that we should be doing in real time. It can benefit from being real-timeified. Is that a word? I'm gonna use it. So my idea of wanting to issue these surveys to my friends in a fun, interactive way, and then analyzing these results in real time is completely valid, and again, as I said, just valid outside of this toy use case of issuing pie surveys. So let's take this general flow, right? If we wanted to do a real-time survey analysis, what are we gonna do? Well, we have to issue the survey, right? Capture that information, have it available in Kafka. There's probably some extra data that we'll need to have. If you're issuing maybe an internal survey on management, you're gonna keep track of who's actually responding to those surveys. There's some employee profile or what teams they're on, some extra metadata. Throw all this into Kafka, do some stream processing, analyze this in real time, and output it, either some visualizations, some output results, maybe throw it somewhere downstream for further analysis. But there's a lot that we can do with this sort of base recipe. And I say base recipe because we're gonna make it a little more interesting here. I am that person. It is what, April? When does Starbucks come out with pumpkin spice? You can totally ignore that if you're not that type of person, but I am that type of person. So let's make this a little more interesting, spice it up a bit. And so this is the enhanced recipe that we're gonna walk through today for this real-time survey analysis, all right? So I wanna be able to keep track of a set of surveys that I can issue to my friends whenever I want. And so these surveys, can be written into Kafka. I'll keep track of them there. Seems like a pretty good place to store my data. To actually issue these surveys and collect survey responses, again, I'm not going to use Google Forms. That's so tired, right? We're going to use Telegram. And for those of you, how many of you have heard of Telegram or use it? It gets bigger and bigger every time. I like that people use this. All of my friends use Telegram now, only because I told them to. It's basically, for those of you who didn't raise your hands, WeChat or WhatsApp, just another messaging application. There's a lot more that it does though, so we're gonna use this and define an application that will issue these surveys to my friends so that they can respond and that data will be written into Kafka for me to capture and analyze, all right? Then we'll do a bit of stream processing to see what pies I should bake, and I'll get an alert and understand what I should actually, if I'm grocery shopping, all right, what ingredients should I get for these pies? What do I need to show up with? So, with that in mind, I mentioned Kafka. How many of you, I always like to phrase this differently every time. How many of you have never heard of Kafka before? Yay, okay, nobody raised their hand. That's incredible. How many of you were at Anna's talk this morning? Only three of you, and one of them was Tim. It was early, it's okay. Well, that's great, there's not too much overlap here now. How many of you are using Kafka in production right now? Still not enough, okay, that's cool. There's a really interesting mix of people here right now. Okay, so then this is good, okay? Before we get into this, Kafka is going to serve as sort of the backbone of this, right? We're using it to store this data, to help me move this data quickly and efficiently. So let's make sure we're all on the same page. We know what we're talking about. This is the accelerated version though. Distributed event streaming platform. That's all you really need to know about Kafka. But we're gonna break it down a bit. It's a streaming platform. I don't need to convince you all that real time is better. You're all here, okay? We like real time, we want results in real time. We want things now and in no other way. And Kafka is a platform, is a technology that allows you to stream data in real time, to move data as close to when it's being created as possible, and then unlock insights as that data is being moved and as that happens. So this idea of stream processing, of real-timifying it, this is pretty cool. You're all pretty much aware of the benefits that you can get from this. And there's a lot of technologies that can help you do streaming, right? Make data real time. Kafka is just one of them. They all have their pros and cons and nuances and cool things and awful things. But we're gonna focus on Kafka here. But generally, this move to stream processing is a good thing, right? It's going to help you, in most cases, increase the accuracy of your data and your results. It's going to make you build a more reactive system. And in the case, if you're using Kafka, you can actually build a more resilient system, a more loosely decoupled system as well. So there's a lot of cool benefits to it. So summary here, Kafka is a platform that enables streaming, enables you to move data in real time. But more than that, it can also serve as maybe a messaging system if that's all you need it for, a persistent storage layer, which is always a nice thing to have, and then also a processing layer, as we'll get into. Okay, but it's an eventing platform. How many of you feel like you are well-versed in events? Not just the people who planned this event. It's very different. Okay, cool. So if you are, which is a great event, by the way. Thank you so much. All right, so to use Kafka well, you can use Kafka and be bad at it, but to use Kafka well, you need to understand what events are and use them to the best of your ability, okay? So you need to start thinking in events. And not enough of you raised your hands, so let's break this down. So this isn't me asking you to rewire your brain, okay? This isn't a huge ask, I promise. As programmers, as analysts, as humans, as users, you already know how to think in and react to events. I promise. Every time you submit a web form online, every time you get a notification on your phone, every time you look at application log files to debug something, those are all events. You know how to interact with them. You know how to work with them. So this isn't a big ask. Just be a little more aware of your data, all right? So those were examples of events, but what are they? So it's just a piece of information, ideally like a small amount of information, that describes something that has happened. That's it. It's not that complicated. Just something happened. Let's write it down. Let's record it, all right? So what do we need to know if something has happened? We need to know when that thing happened. That's pretty critical. A timestamp. We need to know who or what was involved, the subject of that thing, and then any supporting information to sort of flesh out what actually occurred. So going back to this sort of survey-taking application for this PIES, let's say that after I have this up and running, right? Say my friend Alyssa takes the survey, and she said, she takes it at 2:30 p.m. and she decides, all right, apple pie, that's my jam. That's my favorite thing. I want apple pie all the way. Great. So timestamp, yesterday at 2:30 p.m., she took that survey. Wonderful. And it was Alyssa that took it, and she took this pie survey. Great, so we know what was happening. And the supporting detail, what was her response? She said apple pie. That's what she wants. Okay, so it doesn't have to be that complicated. It is an event, something that happened. We can break it down for all things that have happened. But another really, really critical thing about events is that they're meant to be immutable, and I'm so sorry if that doesn't vibe with you, but that's just how it is. So if Alyssa comes back to me today and says, well, I want to change my mind, can you delete that? Well, no, I cannot. And that's not just me being difficult, but that thing happened yesterday at 2:30 p.m. She took that survey, and that's what she said. For the purposes of the system, as little as it does actually matter in the grand scheme of things, that event happened. That survey result was captured, and it has been written. It is there, set in stone for all intents and purposes. But what she can do today is retake the survey. I'm not going to tell her no. She can retake it and maybe change her mind to pumpkin, which is, I don't know, is that a bad move? I think apple pie is pretty good depending on apple cranberry. That's pretty nice. But that's totally valid. She could retake that survey and generate a new event today with a new timestamp that says she took this survey and this was her response. Right? That doesn't invalidate what happened yesterday. We're just adding a new response, okay? We're adding a new event to that sort of timeline of survey responses that we're capturing over time, all right? So just let that sink in with you, okay? Events are important, they're immutable. And based on all this, right, hopefully you can sort of see the good in this, okay? Kafka is a system that allows you to move data in real time, quickly, to stream it, and it's moving immutable facts, which is pretty powerful. If any of you leverage immutability in your day-to-day life, which I hope you do, there's a lot of really great benefits to it. Replicating that data, knowing when new data comes in because you always know where you're putting it when it comes in. You know that you kind of have a golden source of truth. It's never going to change. Bad actors can't really do anything to it. And a lot of people can tap into it at once, right? Because it's never going to change, all right? So Kafka's pretty nice. It allows you to move these facts efficiently and quickly, and these facts are never going to change. But how does it do this? And to understand that, we've got to understand that Kafka is a distributed system, all right? And just a quick primer on how you actually work with Kafka in this distributed nature. So primary unit of storage in Kafka is a Kafka topic. You may have heard that before, nothing new. Topics typically represent a single data set, right? And it consists of events, right? So you get data into Kafka using a client called a producer, and you write data into Kafka as key value pairs. It's a key and some event. And you can have as many producers as you want writing to as many Kafka topics as you want, usually within reason, but you're probably not going to hit that limit as a normal human. From there, you get data out of Kafka using another set of clients called consumers. And again, you can have as many of these as you want, reading from as many Kafka topics as you want. A couple other cool things about consumers. The first thing is that as they read the events from a Kafka topic, they have the ability to keep track of where they've left off. All right, and that's really great just because you want to know, you don't want to reprocess everything every time you reboot your machine. All right, so it does that using an offset. It just stores that back in Kafka so that it knows if it ever goes down and it needs to come back up, it knows where it left off. Consumers can work together as part of a group. It's called a consumer group. And by doing this, they're able to share the load of reading from a single topic or a set of topics and then parallelize the processing of that data. But I think more interestingly is that they also, at the same time, have the ability to work completely independently. All right? So any number of consumers can read the exact same data from an underlying set of topics and not impact the others at all. All right? And that's a really important thing, actually. So for those of you, you all sound like you've heard of Kafka before, but maybe not all of you are using it. So it's easy to compare Kafka to other similar technologies, maybe some messaging queues or whatnot. And I just want to nip that in the bud, okay? Kafka topic is not a messaging queue. It is not. It can behave like one if you really, really want it to, but it's not. Fundamentally, it is not. A Kafka topic is a log, okay? Just like an application log file that you use to debug any sort of system. So what happens when you're reading through a log file? Say you need to debug some system. You're reading line by line through that log file, trying to build up the state of that application in your mind. And every line in a log file is an event, so just let that sink in, right? There's a timestamp. It describes some component of the system and says what has happened at that moment, right? So you can read through that log file line by line and build up that state of that application in your mind and say you need someone else to help you debug. Well, they can come and do the exact same thing, right? That information hasn't gone anywhere. It is durably stored in that log file until the log file rolls, but just ignore that, for some configurable amount of time. And any number of people can come along and read that application log file at the same time. Right, so it's the same thing with a Kafka topic. Okay. Another thing to know, consumers, producers, completely decoupled. They don't need to know about each other. They just don't care. And that's great, right? We like decoupled systems. And Kafka topics are further broken down into smaller components called partitions. So an example over here is we have a Kafka topic with 3 partitions. And these partitions are themselves the actual logs where the individual events are stored. It's append-only log, and these immutable events are stored in them. But why? Why bother? Kafka is a distributed system, so we're going to take these partitions, we're going to store them across the distributed system, and we're not going to get into it, but really this is going to allow us to provide better resilience and facilitate replication of our data later on. All right. That was kind of an aside, but that's a quick primer on Kafka. We could chat more if you have any more questions on just Kafka in general, but let's get back to the recipe because that's the important part here. Getting pie, hungry. All right, so back to the recipe. All right, so this is the high level, what we want to do with this. What do we need to do first? Well, we need a Kafka cluster. I need to put the data somewhere. So I work for Confluent. It's no secret. So when I need a Kafka cluster, I usually just do a Confluent Cloud cluster. So this is just fully managed cloud-based Kafka. I don't have to think about managing anything on my own. I spin up a cloud-based cluster in a couple minutes, and I can start working with it. I don't have to manage any of those components on my own. There's some other things built into this that are pretty cool. Kafka Connect, which is a great way to integrate external sources and syncs with Kafka, which is pretty useful. KSQL DB, you may like it, you may not. Anna doesn't like it, but no. But what's cool is that it's a really great way to do stream processing just in browser, right? Fully cloud-based. You don't have to think about, again, running any application outside of your Kafka cluster. And then we have schema management as well. So a lot of cool things that you can get from using this cloud-based managed Kafka. But if you want to do something similar and you want to follow along and do something like this at home, I don't care where you're running your Kafka cluster. Just get one. Just do it. OK, so we're going to spin up a Kafka cluster. Now what? We got to get some data. Got to start surveying my friends. OK, so with any streaming project, first step, Just get your data into Kafka. It sounds pretty easy. Sometimes it's usually the biggest ask. But all right, let's nail down exactly what this data should look like, though. And I'm going to take a little bit of time. All right, I am that person that I like to be a little, I want there to be a real takeaway here. And I don't care if it's just like, if it feels only like a best practice or just something everyone should adhere to. But whenever you're starting any project with data in it, which is like, let's face it, every project, there's always data. Just think about it, please. Please. I used to work in data warehousing, and every time it was like everyone requested a report. I'm like, do you know what your data set looks like? You're not going to get any of the things that you want out of this. So just anytime you start any project, just think about the data sets you're working with. It's going to save you a lot of time later on, and at the very least, you understand what fields are available to you. Okay. In my case, I am building this data set. So this allowed me to just take a step back and understand what fields are actually necessary, like the minimum number of fields that I need to make this project work. And then I was also able to create, this is so sad, like I have a whole backlog for myself on where I want this project to go and all the different iterations of it. I'm like, I'm ready to go. My friends have no idea what's going to hit them later on, okay? They're just always going to get surveys from me. I'm going to start taking sponsors for my surveys, so anybody. But anyway, so it just helped me reason about like what I actually want to do and get out of this project long term. So let's create some schemas, all right? Doesn't take that much time. It really doesn't. So with Kafka and Confluent Schema Registry, you're free to use whatever schema type you want to use. Avro, JSON, schema, JSON schema, protobuf. I personally use Avro. That really, I think, comes down to personal preference. I like using Avro in my Python code, so this is what we're going to go with. So first up, for the meat of the project, meat of the data, these survey responses, okay, that I'm actually capturing from people that we're going to ask from my Telegram application, and they're going to respond. And this is the data that's going to be generated into Kafka. So what do we need? Okay, some user information. Who is actually responding to this survey? I also have, just their name, user ID that we'll be capturing from their individual chat instance in Telegram. Their company, if they want to put that in. That sounds kind of weird that I'm asking my friends for their company. Well, people change jobs so frequently now. I can't keep up. This is like my way to have my Rolodex and like keep track of where my friends are if they want to respond to it. It's optional. Their location, again, they're moving all the time, and their response to that individual survey ID that we're also capturing. All right, so this is like I said, the biggest data set that we'll be working with here. And then, this isn't a very normal, this data set is not normalized. This hurts me a little bit. I feel like I need to extract the user information from the survey information, and I'm capturing it at the same time within the Telegram application, so I'm going to just capture it at the same time. I'm so sorry. We're going to package it into one message, and if I, at any certain time, want to leverage the individual data sets, I'm free to extract those, and we'll see how to do that later on and leverage those. All right? So let's extract the user data. I just want to be prepared with the schemas so I don't have any surprises later on. So these are just the people responding to the survey questions. So we're extracting the username, the user ID, the name, company, and location optionally. Pretty simple to create this, just extracting the subset of fields that I want. Also, these survey responses themselves, again, just extracting the survey ID, the user ID, and the individual response from each of them. But what is a survey ID thing? That's kind of like a little hand-wavy thing. What do these actually correspond to? Well, I do have a broader agenda for this application, right? I have that whole backlog of items for me to work on. And the wider agenda is more than just Thanksgiving pie surveys. Watch your inbox. But really, I just want to be able to issue and enable and disable any number of surveys that I want long term. I really want to inundate my friends. I want them to hate me for this application. I'm going to get so much information out of them. So I wanted to be able to store the individual survey questions that I might want to work with. And I also have an additional flag in there for enabling and disabling. Like, obviously, right now is not the best time for me to ask my friends about their Thanksgiving pie preferences. So that survey should maybe be turned on in, I don't know, October. Now, I'll probably ask in like September. But anyway, so I want the ability to change these things and update them over time, add new surveys if I wanted to. So I figured, let's persist this data to a topic in Kafka and keep track of it. All right, but for now, the only question we have in mind is, all right, what is your favorite Thanksgiving pie? Okay. I don't want it to get unreasonable, so I did limit the number of responses, or the types of the options that they could respond to. I picked from the pies that I'm like actually good at, decently good at, because I didn't want them to request something ridiculous. So we're going to limit it to those options. I provided a summary field in there as well, so I can just actually look into this later and understand what survey we're looking at. And of course, we're enabling this one. All right. So we understand how these data sets should look. We created some schemas. It didn't take that long, right? So let's get the rest of the data into Kafka. I'm just going to take this first survey, write that into Kafka directly, but the rest of it, we got to get it in there. And for that, we have to write a Telegram bot. So I'm pretty excited. Half of you understand what Telegram is, and this is going to just change your life if you haven't been doing this already. I love using Telegram. I love that you can create a bot with it. That's what makes it, just excel over other messaging applications, is that you can create a bot account. And when you do that, you are just given an API key that you can use to interact with that bot. And the cool thing is that there is a Python wrapper around the Telegram API. So you can just write a Python script using that API key to authenticate your bot and define conversations that people can have with this bot. Like anyone could go search for this bot, please don't, can search for this bot and start taking surveys on it, which is great. I can just point my friends to it and they can interact with it, right? So let's go ahead and do this. So again, like I said, once you register a bot, you're given an API key. And you use that to validate your bot within your Python script. And so then at a high level, what I'm doing is just defining like a survey-taking conversation. How would someone interact with a bot so that the bot can capture their responses to a survey and then package it into a Kafka message for me, right? Well, let's define a conversation handler. All right, so this, I'm basically just defining this survey command in the Telegram bot. And we're going to break it down by the individual states that someone would go through when they're having this conversation. Like if I were walking around, with a clipboard in the mall asking people what their favorite pies were, what am I going to do? First thing, what is your name? Well, what age group do you fall into? Probably that. But okay, what is your company? Where do you live? And tell me what your favorite pie is. Do it. So that's the sort of, we already do that sort of transactionally, just like go through that process of requesting the individual fields. So I'm going to make this bot do the exact same thing one at a time. So you see here, we're breaking it down. First, I'm going to go through the name state, requesting the name from the person that is responding to the survey. Go through that, ask for their response to the actual Thanksgiving survey. And then, is this data correct? Confirm it, yes or no. So at every stage, you're basically just defining what is the function that is going to handle extracting this information or responding for this bot, and then forwarding to, the user to the next state of that conversation. Okay, so it's just like a finite state machine. It takes a little bit of reasoning to get through originally, but after that, it's pretty easy. And you're going to want to do this for literally everything. It's so much fun. So let's dive into one of those function handlers really quickly. So this is the name function handler. So here I've already prompted the user for their welcome message. You're going to take a survey. What is your name? And the user has already responded with something. So what I'm doing is I'm taking that user input from the input message. I'm extracting that and I'm storing it in just a temporary state within this conversation, just in a dictionary mapping of name and capturing what they input. I'm also grabbing their chat ID because I want to use that as the user ID as well. And then I'm prompting them for the next bit of information. It's a little more complicated here because I want it to be optional. So I'm asking for their company, but if they don't want to answer with that, then they can just skip. And it's going to go to the next state in the conversation. All right? And we're going to do that for every stage of the conversation handler. And at the end, once they've confirmed that their data looks good, we can go ahead and produce it into Kafka. And this is all going to be hidden from the user. They don't have to know what Kafka is or how to deal with it. It's perfect. It's great. Okay, so what we're doing here is we're extracting all that data that we're capturing from the survey itself in this sort of entry dictionary. We're taking that, we're packaging according to, taking it from the dictionary to the entry type as defined by that schema, and then we're producing it to Kafka. I had a few helper scripts in here to sort of extract out the not very nice looking code, but it really isn't that complicated to set this up. I had a serializing producer, just another helper script to again serialize that, to know how to take those serialized bytes and produce it into Kafka. And yeah, there's not much more than that. I do have the source code linked at the end of this. You can take a look if you're curious to check it out. And then the rest of the boilerplate code that needs to happen to get this data into Kafka and have the bot be responding and dealing with these messages, that's all handled by Telegram. It's completely abstracted away, which is really great. So when I run this script, and I just have it running indefinitely on my Raspberry Pi, this is what I see when I'm going to interact with this bot on Telegram. So when you first want to talk with the bot, it's going to present you with your different conversation options. Right now, it's just survey. All right, I want to take a survey, and it's going to prompt, like I said, for that user name. Enter the company or skip if you want, and you can go through here. And when it gets to the actual question itself, there's a finite list of responses, right? So it's going to present those as just buttons that we select. Don't have to type anything in. Don't have to worry about it. And then finally, we'll confirm that data, and after that confirmation, it will produce it into Kafka. If for some reason it fails, the produce, it's going to ask to try again, right? Or maybe retake it if you really feel like this was your chance to respond differently, right? All right, and so once that's running, back in November, I was able to run this and just tell my friends, go take this survey, right? Look into this and take the survey, respond to me, all right? They were a little annoyed, but it worked out. The data was flowing in. And this is what I saw on the Confluent Cloud Console, just those messages flowing in over time. All right, so the data is in Kafka. Our data sources are connected. We see that data flowing in, so let's start analyzing it. Let's start processing it. I'm a decently big fan of ksqlDB. I'm so sorry, Anna. But I like that it makes stream processing easy for a lot of use cases, all right? There are other options for stream processing in Kafka. You are free to use the consumer and producer API. If that's your jam for certain use cases, that's completely valid. Kafka streams, if you want to do something a little more intense, maybe some elementary analysis, you should watch Anna's talk if you haven't. But then if you really don't want to be working within Java, then maybe ksqlDB is going to be pretty useful for you. What I like is that it's a sort of a SQL wrapper on top of Kafka streams. And so it just makes stream processing that much more accessible. If you've used any other of the streaming SQL, you know how great it can be. All right, but ksqlDB is really great at defining stateful aggregations using SQL, and I also like that you can run it within Confluent Cloud, within the GUI, so you don't have to run any applications separately. So that's what I'm going to use here. And so I'm going to spin up a ksqlDB application and start interacting with my data. But the first thing you need to do is get the data into Kafka, all right? The bare minimum, just get it in there, all right? So I need to load my survey entries as input into ksqlDB. And as you should know that there are two main constructs in ksqlDB. There are streams and there are tables. All right, so the first thing you need to do is decide how your data should be represented. So streams are going to represent ongoing sort of series of events where every event could potentially be relevant and we should keep it and we could be able to work with it. Whereas tables are sort of a representation on top of streams, right? It says it's going to represent the underlying data set in such a way that only the most recent value per key is maintained. Okay, so if you think back to my survey questions, right? I have that enabled flag that every time I flip that, great, but I want to keep the most recent value. I want to know that that's the most important part. I don't care how many times I've turned it off and on. I want to know what the latest value is because that's the state that I care about, right? All right, so looking at my survey entries data set, I'm going to use a stream here, right? Every event, every time someone responds to this survey, that's important. That's driving my analysis, so I should keep every event, okay? And I should analyze it and process it. So we're going to use a create stream statement, and there's really not a lot here, right? This is a pretty sparse statement. So you remember I defined a schema. We took a couple extra minutes to do that in the beginning. So all I have to do in this create stream statement is point to the underlying Kafka topic where these events are stored. It's that survey events topic. We're going to specify the value format, which is Avro. I defined an Avro schema. And then ksqlDB, as a Kafka consumer, can access the schema registry for this topic, find the schema associated with this topic, and then use that schema to parse the fields and their types. So I don't have to specify any of the fields here. As soon as I execute this, we're going to have a stream called survey entries as input into this KSQLDB application, and it's going to have all those fields and values brought in for me. I don't have to think about that. No typos. That's great, all right? So we're going to run that, have that data present in the KSQLDB application. And now, just so that you know how easy it is, I'm going to normalize this data. And this is a best practice for, if you're trying to create data products, right? You have to think about what is the data set that's actually useful to people downstream, to other applications. And so in this case, it might be useful, for myself, if I'm building up sort of a catalog of all my friends and where they work, it might be useful to extract just the respondents and have that stored somewhere in a separate topic for me to use. So here I'm just creating another stream based off that survey entry stream for the respondents and only the respondents. So you see here, we're doing kind of similar to what we did before, defining the Kafka topic where these respondents, this data should be stored. What the value format is, we're going to use avro again. And then I'm just doing a select statement on top of the survey entries stream, and we're selecting that subset of data that is relevant to this data set, right? So we have the user ID, their name, their company, and their location, okay? Okay, so we're first creating that, blah, blah, blah. There's the select statement, and if I just run this select statement as is, what's going to happen? I mean, you might not know, but if I just run this select statement as is, it's only going to output what is in this Kafka topic right now, right? What is there currently, and then it's going to stop. But I want this data to be persisted, right? If I want to use this, or if someone else wants to use this data set, every time a new entry comes in, I may need to extract new data, and I want to execute this statement and append that data to that stream. So we're already appending it to the stream by executing this as part of the create stream statement, but it's just going to stop when it runs out of data. So I'm going to add emit changes to the end of this statement, and what this says is that every time an event flows in on that underlying survey entries topic, we're going to execute this statement, extract that subset of fields, and we're going to append it to that stream. So this is going to be an ongoing persistent query that's always going to be processing and extracting that data, right? And this is called a push query. A pull query is just what I described earlier, where it just gives you what is there currently and stops, okay? All right, so next I'm going to do the same thing, normalize that survey responses data as well. And again, just selecting that subset of fields that is relevant for this data set, and executing it just in the same way. So by doing this, just a best practice to consider if you're building up or trying to be taken seriously with any sort of data products. So just normalize your data, make it clean and easy for people to interact with it. This is what I'd recommend doing, all right? So I've extracted those respondents and the responses, and they're available for me to use. But I'm going to go back to the survey entries eventually, but there's one data set that we need to bring in as well, and that is the survey questions, right? Remember, those are there. Those are floating around. We only have one question in there for now, but I will need that eventually. All right? This is the last one we have to bring in as a source here. For the last few data sets, we were using a stream, right? Every event is potentially valuable. We want it to be streaming in. But in this case, the survey questions, as I said, have an enabled flag that I could be flipping whenever I want. And maybe, there was a typo in one of those fields, and I want to update that. And I only want that most recent value. Okay, so that's a perfect candidate for something that should be stored in a table. I only care about the latest value per key, in this case, per survey ID. So we're going to create a table here. So pretty similar to a create stream statement. We give it a name, survey questions. We point to the Kafka topic where that data resides, specify the value format, and it's pretty much the same. It's going to go grab that schema from schema registry, extract the fields for me, and move on. But because it is a table, and a table keeps the most recent value per key, well, it needs to know what key we're dealing with, all right? So we need to define a primary key for this table, and that's the only field that we actually have to specify here, is which is going to be the primary key for us, all right? So that's the only thing I had to specify. And once I've run that, that's going to be available in my application as well as input, and all that remains is to actually analyze this enriched data set, right? And I'm pretty much only interested in the aggregate of this. I'm asking a pretty simple question, and I just want to know how many people are voting for each of these options, right? For each of these pies. And KSQLDB actually makes this pretty easy with a histogram function. So we're going to conduct an aggregate. We're going to select the question, per survey question, we're going to create a histogram over the responses. So what this is going to do is just aggregate the individual responses and show you how many folks have responded to each of those. And we're selecting it from the underlying survey entry stream, again, grouping a question, and we're going to emit those changes, right? So a couple things to break down here. We are creating a table as a result of this. And that's just because every time an entry flows through on the survey entries, we're going to conduct this select statement, right? We're going to look at the question, group by that question, and we're going to do that histogram. But if I have, 25 responses, we could potentially have we will have 25 output events. They're just going to be partial output events. Every time one flows through, we're going to see the updated histogram, and we're going to get, at the end, the sum of that histogram is going to be 25, right? So for every incoming event, we're going to have an output that's going to be aggregated by that question, and that question is going to serve as that key. So the latest value per key, we need a table, all right? The output is a table. And so here's a sample of sort of that, the sample output that's going to be output as part of this. So for that pie, breaking it down by pumpkin, pecan, apple, and whatnot. All right. So this is what I'm going to see as an output as we're processing these events in real time. But, and that's great. I could be monitoring the Confluent Cloud Console and just check this out and make a decision based on the output. But what if I don't care about the real-time results? I know. We did all of that work. What if I don't care? I do care, but what if I just want one, I can be monitoring this whole time, but what if I just want one final result? Tell me. I'm on my way to the store, tell me in 30 minutes what I should be doing, right? Maybe I only want to see these results. I'm going to give my friends a very artificial deadline of you have 48 hours, respond to this, or your opinion does not matter, okay? And I've done that many times to my friends. But anyway, so it's pretty simple to do this, right? All I have to do is change 2 lines of that query, all right? So the first I'm going to do is define a tumbling window, so a non-overlapping window of size 48 hours. We're going to give it a grace period of 10 minutes for some late arriving events, just in case. And so what happens is every time a survey a response flows into this, we're going to bucket it according to that window. Is it valid? Is it valid? Did it happen within that 48-hour window or not? And if it does, then we're going to execute that histogram, all right? And then, instead of using emit changes, I'm going to update it to emit final. So the only time I'm going to output a result after this has been executed is after that window has finally closed, all right? After that window is closed and that 10-minute grace period has passed, then I'm going to see an event output. So it's going to be that final histogram with all of the results that I wanted to see as sort of a summary, right? But how useful is that? All right, it's in Kafka. What am I going to do with that? Again, I'm not going to be monitoring Confluent Cloud the entire time to see the result of this. So let's get this data out of Kafka. I don't want to be tied to my computer, so let's make use of it. Let's get it back onto my phone, okay? So I mentioned a bit earlier that Kafka Connect is your way to integrate external sources and syncs with Kafka. So usually that's done, if you're pulling data from a source database, Postgres, or moving it out into S3 maybe. But it's very, very flexible. It's defined for a lot of different sources and syncs, and it's configuration driven, all right? All you have to do is point to your source and define how to actually interact with it, how to access it, what are your credentials, and it's able to, in the case of a database, extract any updates on a table and move that into Kafka. And it can do the same as a sync. So a lot of these connectors are available fully managed. So Connect is a framework that operates alongside of Kafka. It's something that you kind of have to run in a separate cluster if you want to use it. But with Confluent Cloud, a lot of these connectors are available fully managed, meaning that you don't have to run any of them. You just have to define the configuration or enter your configuration parameters and start running it. And one of the fully managed connectors is an HTTP sync connector. And so if you have an endpoint that you can send data to, well, all right, you can point to a Kafka topic and move that data out to that endpoint. So I need an endpoint. Well, Telegram gave me one, right? They gave me an API key to access that bot, to interact with that bot. And I also have a unique chat ID that I use that defines the conversation that I have with that bot. So using those two in conjunction, I'm able to define an endpoint that I can send data to. And so that's what I'm going to use. I'm going to point to that topic of final results and to that endpoint, and we're going to move that data to, as that window closes, to my phone, all right? So I'm going to configure that connector, start it running, and after that window closes, this is the sort of, I did a little bit of finagling, a little bit of cheating here, switched it from text to emojis, but every time a new event is output to that final summary results table, my connector is going to move that information to my phone, and I'm going to get a result as soon as that window closes. All right? So if I'm at the grocery store just waiting to know, all right, what am I going to buy? In this case, pumpkin and apple. We're going to get a bunch of that. And those are the 2 pies that I'm going to make for that particular Friendsgiving. All right? So we're getting to the end here. In case you forgot, there was a point to this. We did achieve something, all right? It wasn't just me and my pie. We played around with Telegram. I hope you're inspired. I really love using Telegram for just fun, random use cases. It's almost unfair what you can do with it. We were using it to embed a Kafka producer to get data into Kafka pretty easily from people that have no idea about Kafka and don't need to know about it. Well, they do know. They're my friends, and I talk about Kafka all the time, so poor them. We saw a little bit about what we could do with stream processing, mostly with KSQLDB, and finally you got a quick glimpse of Kafka Connect and how we can move data out of Kafka pretty easily and get it back onto my phone. And there is a final stage of this. I actually did bake some pies as a result of this. I did do something in the end. If you want that recipe, you will have to follow me on Twitter. That's my shill. But a different type of recipe. I hope you'll take a look at it. Because of the usefulness of real-time survey analytics. I promise, remember Business Danica, I did convince you of that in the beginning. I don't know if you agreed, but I did adapt this presentation to what my team calls stream processing use case recipes. So, recipes are all the rage in tech right now, right? How do you do something really quickly for a specific use case? So this is a really cool portal that we have on Confluent Developer where you can browse a lot of really different and interesting industry use cases for things that maybe you didn't think Kafka could actually work for. And it's really fun. You follow the recipe. It's going to launch everything in KSQLDB for you. And you can really hit the ground running and just play around with different use cases quickly. So the real-time survey analysis recipe is on there if you want to start with something simple and play around with any sort of data. So I hope you check it out. Here's a link to my link tree. I have the source code up there. I've got the Confluent developer resources and a couple other things. I forget what it is, but check it out. And now we are very much at the end, so I will open it up to questions. Thanks for staying awake. End of the day. Appreciate it.
What was the most popular pie?
Ooh. It actually varied across different events. So that was the interesting thing. You don't realize it until you actually think about your friend groups. That could be another parameter. But I don't want to give my friend groups friend group 1, friend group 2, but maybe I should break it down like that. But my friends from the East Coast, from back home, pecan pie, that was a thing.
Yes.
Yeah. Out here, I had someone request a lot, I don't know if you noticed, the leftover pie, because I went to so many Thanksgiving dinners that it's oh, I actually do have leftovers. I can make a pot pie for Thanksgiving with my leftovers. And a couple of them, they're just weird people, so. But it was interesting. It was interesting to see the breakdown.
Oh, thanks for the talk.
Yeah.
I wonder if there are a lot of paying customers of Confluent who actually do real-time analytics for surveys.
For what?
For
For surveys?
Yeah.
I don't know. Anna, can you speak to that? Do you know of any customers that do that?
Several.
Yeah?
Oh, okay. Is there a big demand for that?
So more and more, yes. People get overwhelmed with surveys these days. So what they actually do too is they'll send out the surveys, and then whatever facilitates that surveys, whether it's email, whether it's text, they'll measure the response rate. So yes, all over the place.
Cool.
A lot of times, all of the real-time stuff you get on your phone from your bank and all that, thank you from that's all driven by Kafka.
Oh, cool. Interesting. Yeah, because I'm from employee engagement software company. So that was very interesting. Thanks.
We can't say
Cool.
specifics.
Yeah.
I'm walking non-disclosure agreement, but I just say some customers.
Yeah. Thank you. Yeah, I'm not always in the field with the actual customers, so thanks for that input.
Thank you.
Cool. Thank you so much.